Alright, so for the problems we have gone over before, up to this point rather, so we have used a force as for the force, the weight, which is in the English system. So in this case, we also going to work in the metric system, which is the most common systems to work with. Well, so one thing to keep in mind is that in the metric system, it is the mass of an object. It's not the same as the weight, because the mass is a measure of a body resistance to change in motion. So in this case, to compute the gravitational force, we need to use the fact that force equals mass times acceleration, where A represents the acceleration due to gravity here on Earth. Well, and you know that value, if you have taken a physics class or basic science class, of course we can express this formula this way: force equals mass times gravity. So that's just to give a more specific symbol for this value of A. And also, in addition, so mass, it's again density times volume. And again, since we're looking at this force and displacement for one-dimensional situations, well, we get the mass by multiplying the density times the length. All right, so let's look at one example. So a 10-meter change with a density of 2 kilograms per meter hangs from a platform at a construction that is 20 meters above the ground. Well, so compute the work required to lift the change to the platform, and well, we'll look at letter B soon. So let's make a little drawing here, of course. So right here is y equals to 0. However, in this case, be careful, because the chain that is being pulled, it's not 20 meters, it's only 10 meters. So be careful here. So right here, okay, let me draw like a pulley. Okay, and so in this case, just 10 meters, you know, that's the length, 10 meters. Okay, and in this case, well, so that's y equals to 10 in this case then. So as usual, we're gonna look for the differential for one little tiny piece on the chain. Well, if this is, so right here, where this is y, this is 10 minus y. These are the 10 meters right here, the whole thing. Alright, so first of all, we need a force function, and well, recall from earlier that force equals mass times acceleration, which in this case is the one due to gravity. Well, but in this case, first we need to figure out what the mass is. Recall that the mass is the density times the length, right? And in our case, the density, which is 2 kilograms per meter, that's the density of the chain. And what else are we given? The length, which in this case is just some delta L. And in this case, this delta L is in meters. Notice how we can cancel these units right here. Cancel meters with meters. And well, this will be 2 delta y kilograms. You'll see about the units in a minute. Well, so coming back to the force function, well, we can now write the work done by this force as the force, which is in this case the work, which is in this case the integral from 0 to 10. And this is going to be, well, 2, which is the density, times 9.8. This is the 9.8 that will go, let me highlight it. This 9.8 will go with this gravity value here. So force times the distance, and then in this case, well, whatever distance that change is left to cover, which is 10 minus y. dy, of course, just to be consistent with the units here, this 2 times dx go together right here and are both kilograms, and this 9.8 is meters per second squared, and these are meters, the 10 minus y. Alright, well, so we can compute this integral right here just using the graphing calculator, and that's fine. And the final answer is 980 joules. Well, how do we get those joules? So be careful with the units because, okay, number one, so in this case, we're gonna get, when we simplify all these units will become kilogram meter squared per second squared, which are joules, also known as Newton meters. So that's from the decimal system. Okay, so not in this case, no more feet pound, so Newton's meter, which are actually joules. Okay, so a bucket filled with tools is attached to the end of the chain. So the mass of the bucket and the tools combined together is 10 kilograms. How much work is required to lift the chain, the bucket, and the tools to the platform above, the 10 meters above? Well, so in this case, keep in mind that the bucket with the tools do not suffer a smaller size as they're going up, as the chain does. You know, the density of the chain becomes smaller because the chain being the part of the chain that remains hanging. So in this case, the weight of the bucket and the tools remains constant, and for this reason, no calculus involved. So all we have to do here is find the force times mass times acceleration, which is mass times gravity. In this case, the mass, which is 10 kilograms, combining the bucket and the tools, times 9.8 meters per second squared. So, which in this case it's 98 newtons. That's what kilograms meters per second squared are. Alright, those are the newtons. And well, now that we have the force, let's find the work done, which is work equals force times distance. And in this case, this is going to be 98 times the distance 10, which is 980. Yes, the value is very much the same as before. That's just a simple coincidence. It's nothing weird. These are joules. And of course, because they're asking us for the total amount of work, well, so the total amount of work equals chain plus bucket with tools. And in this case, the work done by the chain was 980 newtons, plus the work done by the bucket and the tools is also 980 newtons, totaling 1960 newtons. All right, so this was the last example, and this is a good place to quit for this section.